So in our first example, we had just 1 over x. If we consider the original function x minus 1, and we call that f of x, then the reciprocal of this function is 1 over x minus 1, 1 over f of x. Okay, so keeping that language consistent. The graph of y equals 1 over f x minus 1 has no x-intercepts, and we see it over here on the right-hand side because it is never 0. The output is never 0. The x-axis is a horizontal asymptote of the graph. So again, we see this is our x-axis. I'm never coming into contact with the reciprocal function. Okay? So you can't really see the dashed lines very well, but they are there. We have a horizontal asymptote at y equals 0. In this case, my non-permissible value is at x equals positive 1. Okay, so x equals 1 is my non-permissible value, so I find that out by taking x minus 1 cannot be 0. So x cannot be 1, okay? That's where that's coming from. So again, I have my vertical asymptote here, and I'm going to label it as x equals 1. This asymptote passes through the x-intercept of my original function. This will always be the case. So our x-intercepts, because that's when y equals 0, will always give us our vertical asymptotes, because that will no longer be allowed when we are going 1 divided by our output, 1 divided by that original y value. Okay. So, how to graph a reciprocal function in general is that we find and plot the y-intercept of any line, if any. Okay, so let x equal 0. And we'll figure that out. Okay. Find and plot the x-intercepts of the numerator, if any, y equals 0. Find and sketch the vertical asymptotes by finding the non-permissible values in the denominator. Find and sketch the horizontal asymptote by using the rules y equals 0 is the horizontal asymptote. Okay. Now again, this is exclusively a grade 11 rule, and things change in grade 12. Okay, plot some points on either side of the vertical asymptotes to show where the curve is positive and where it is negative. Use smooth curves to complete the graph between and beyond the vertical asymptotes. Now we see that word between. We only have one vertical asymptote right now, so we don't need to worry about the between piece, but when you get to the next lesson, that will come into play. They are called discontinuous, is the word we use for reciprocal functions, because they have asymptotes. So I can't just take my finger and start on the left-hand side of my curve and follow it and get all the way to the right-hand side without lifting my finger. That's what makes it discontinuous. So let's try it out. Example 1. For each of the following functions, determine the reciprocal, determine the equation of the vertical asymptote, graph both of them, and state the domain and range. So, A. The reciprocal of this function is going to be (1 over 2x plus 5). Now, if you want to write it as y equals, that's totally fine. Either one. Okay, where is my vertical asymptote? Okay, well, B. My horizontal asymptote again is always at y equals 0. My vertical asymptote is my non-permissible values. So that's going to be when 2x plus 5 equals 0. Move it around and we get x equals negative 5 halves. C, graph them both. Okay, so I know that I've got a critical point here where I'm going to have a vertical asymptote. I also know that for my original function, because it is linear, this is my y-intercept and this is my slope, because it is in y equals mx plus b form. Okay, so I've got some values to work with. I'm not going to be going a whole lot negative here, so I'm going to maybe put my x-axis a little bit lower down. Okay, so I've got that. It's also going to be a little bit left because my vertical asymptote is on the negative side instead of right on my y-axis. So I'm going to put my origin actually quite off-centered. My origin is going to be right here, y and x. And I'm still going to go up by halves because I do have that half value here. Okay, from here you can make a table of values, or you can use your sense of linear relations, whichever one. I'm going to graph my original function f of x in red again. So I've got my y-intercept is at positive 5, and I've got my slope is up 2 over 1. Remember, rise over 1, run. So up 2 over 1, well, that takes me off my graph, so that's not super helpful. So I'm going to go backwards. Down 2, left 1, or left 1, down 2, down 2, left 1, down 2, left 1, down 2, left 1. And now I've got my line here. There we go. So that's f of x. My vertical asymptote is going to be at negative 5 halves. So that's right here. You can count them out nicely because of how I scaled my grid. My horizontal asymptote is going to be right along my x-axis. From here, I need to choose some points. So again, whenever my output is 1 originally, I'm going to have an invariant point. So those guys are going to stay the same. To choose another point over here, I've got my original output here is negative 3. So now it's going to be negative 1/3. And so what my graph is going to look like, it's going to have the same shape as that other one that we drew, just kind of squished into that corner there. Up here, I can do the same thing. 3 is 1/3. 5 is 1/5. So again, we're getting really darn close to that y equals 0. And we could even do 1/7 there. So we're getting super close to that x-axis without actually touching it. And here we get bigger and bigger and bigger. Because even though we don't have a specific point, we are dealing with reciprocals of fractions, so we get larger values. There we go. So that's, in a nutshell, how we would graph these. Again, you're more than welcome to make a table of values. There's nothing stopping you from doing that. So that's C. D, stating my domain and range of my reciprocal. So looking at the blue. Domain, again, remember, is my input. Those are my x values. So my only restriction is that x can't be negative 5 halves. So if I want to use interval notation, I'm going to go to negative infinity because I can still go left forever, but I have to stop at negative 5 halves. Because there's no point there, I use a curved bracket. I can then signify that it continues somewhere else, specifically on the other side of negative 5 halves. and it goes to positive infinity. If you prefer set notation, sometimes this is actually easier. X is an element of the reals where x cannot be -5/2. So whereas I love interval notation when we're dealing with continuous functions, once we get to discontinuous functions, they're a little bit uglier. Range is the same. I start from the bottom and work my way up. So -infinity, it does keep going downward forever, but I've got a ceiling at y equals 0, and we never get to y equals 0, so we use a round bracket. It's united with, on the other side, I'm going to start just above y equals 0, so again, round bracket and 0, and I can keep following my graph forever upwards, so positive infinity is available too. Again, set notation isn't a bad thing to use in these instances. That's why we keep seeing both being used, so that you get comfortable with the idea and choose whichever one's more appropriate for you. In this case, y cannot be 0, though. That's my only restriction. So what I'd like you to do is give this next one a shot. Okay, you've got a few more to try. Okay, and then the next video is going to pick up at example 2. Just a quick heads up. Watch out for taking out common factors when we're figuring out our non-permissible values as our vertical asymptotes.